Uh, this is going to be the third of three uh, on the subject of does science point to God? And then our specific focus, as you know, is concerning the recent findings in science, which are beginning to show to a remarkable degree the many factors that appear to that must be finely tuned in order for there to be advanced life on planet Earth. Now, as you know, um, it is not surprising to us that everything is finely tuned, right? Because we believe that what the Bible says is true. Uh, And I want to just read a few verses to you so we have it kind of fresh in our minds what the scriptures say about creation. So I'm going to read to you Genesis chapter 1, verses 1 through 8, but just listen again to what the Bible says. In the beginning, God created the heavens and the earth. Now, the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering over the waters. And God said, "Let there be light," and there was light. God saw that the light was good, and he separated the light from the darkness. God called the light day, and the darkness he called night. And there was evening, and there was morning the first day. And God said, "Let there be an expanse between the waters to separate water from water." So God made the expanse and separated the water under the expanse from the water above it. And it was so. And God called the expanse sky. There was evening, and there was evening, and there was morning the second day. All right, so I'm going to stop the quote right there. Now, one of the testimonies that I love to hear is the testimony of Hugh Ross. Because even at a young age, because he was an astronomer from the age 17, when he read the Bible, specifically the verses that I just read to you, he was startled because what he noticed was that in this holy book, unlike what he saw in other holy books of other religions, in this holy book called the Bible, it listed 13 creation events, and this holy book got 13 out of 13 in the correct order. And that just got his attention. He was an atheist, but he was shocked. What in the world is this? Well, how is it that the Bible has all of this in exactly the right order? Now, some people have said that the Bible is not reliable because it says that light was created first, and then after that, the sun and the moon and the stars were created. But Hugh Ross noticed that before you read the 6 days of creation, you have to read the first two verses to find out what conditions, what the initial conditions are. And what we see is that the Bible says that God has already created the heavens and the earth. And then he tells us what the initial conditions of the world or the earth was like. So this morning I want to start off with a short video of Hugh Ross speaking about this on a talk show that was hosted by Alyssa Childers, of all people. Some of you recognize her because she was at one of the events that Ray Siervo had over at Long Branch Covenant Church. And but here she asks him to tell about how he saw the scientific method at work in the book of Genesis. So this is only 1.5 minutes, but listen to this video about the testimony of Hugh Ross. Carol, Carol Whelan, can you turn off the lights in the sanctuary too?
You mentioned that you saw the scientific method in the Bible, and I've heard you even say that that's actually where we get the
Yoshiko,
scientific
can you
method.
make it a
Can you
little
expound
louder?
on that a little bit? Where did you see that, and how did
Oh,
that really
Carol.
apply to your journey of discovering faith?
Well, I saw it right on the very first page. I mean, it pops right out of Genesis chapter
That's good.
1. Step one of the scientific method, do not interpret until you establish the frame of reference or the point of view. Step two, do not interpret until you establish the starting conditions. And what you see in Genesis 1 2, before you get into the 6 days of creation, the Spirit of God is hovering over the surface of the waters of planet Earth. That gives you the frame of reference from which to interpret the 6 days of creation. Then it gives you 4 starting conditions. Water covers the whole surface of the earth. It's dark over the whole surface of the waters, and the earth is empty of life and unfit for life. And then step 3 of that biblical or that scientific method is simply look at what happens in the experiments or the observations and note what happens when, where, and in what order. And you see that in the description of the 6 days.
Okay. So, in other words, when God said, I mean, based on what Hugh Ross just said there, when God said, let there be light, He's not creating light. He already made light. He already did that. He's saying now, let the atmosphere of earth be changed so that light is permitted to reach the surface of the planet. So it's the beginning of light shining on planet Earth. And then when he says, let there be an expanse or let there be sky, what is happening at that point is now God is saying, let the atmosphere be transparent. Let the atmosphere be such as it is now. And then, let there be plants, et cetera, et cetera. So the Bible does not say that we evolved, but it is showing that step by step, God created things and initiated creation events, all for the purpose of finally doing this. And I'm going to read to you now Genesis chapter 1, starting at verse 26. This is kind of the grand finale of God's creating work. So starting at chapter 1, verse 26, it says this. Then God said, let us make man in our image, in our likeness, and let them rule over the fish of the sea and the birds of the air, over the livestock, over all the earth, and over all the creatures that move along the ground. So God created man in his own image. In the image of God, he created him. Male and female, he created them. God blessed them and said to them, be fruitful in number, fill the earth and subdue it, rule over the fish of the sea and the birds of the air and over every living creature that moves on the ground. God saw all that he had made, and it was very good. And there was evening and there was morning the 6th day. All right, so God's final act of creation was to do what? Was to make man. But not just to make human beings, but to make them in his image, so that we might live for a glorious purpose. We kind of talked about that this morning. And what is that purpose? It is to live in fellowship with this living God and then bring glory to him with our lives and enjoy him in our lives. That's what we're here for. This is what the Bible tells us is true about the purpose of human life. We are made for God. Part of enjoying God is simply rejoicing in the magnificent, over the top beauty of God's creation and the wisdom of his creation and the intricacy of his creation. He has made us the crown, and that is for the purpose of his glory, not for our glory. So having said all this, I want to remind you of the focus of this lecture. Even though the popular culture is still being influenced by the so-called, as I talked about earlier, this culture is still being influenced by the so-called Copernican principle, which is that, because we discovered that the Earth is not the center of the universe, therefore, supposedly, Earth is not significant. We're just a pale blue dot. We're just one of billions of other planets. We're nothing special. That's what the so-called Copernican principle says. Science, especially in recent years, is adding more and more evidence to show that, in fact, Earth is special. Very special. That's the startling thing that's been happening in recent decades. An enormous number of things have to be exactly right in order for advanced life to exist. And so what I want to do for you today is I want to read you a quote from Michael J. Denton, who is a senior research fellow in human molecular genetics at the University of Otago in New Zealand. And this is from a book that he wrote in 1998, which is called Nature's Destiny. And this is what he says concerning what the Bible claims, which is that human beings are the crown of God's creation. God made it so that human beings are actually the crown of creation by God's design. And now listen to what this man says about that. So this is a quote. No other theory or concept ever imagined by man can equal in boldness and audacity this great claim that all the starry heavens, that every species of life, that every characteristic of reality exists to create a livable habitat for humankind. But most remarkably, given its audacity, it is a claim which is very far from a discredited pre-scientific myth. In fact, no observation has ever laid the presumption to rest. And today, 4 centuries after the scientific revolution, the doctrine is again re-emerging. In these last decades of the 20th century, its credibility is being enhanced by discoveries in several branches of fundamental science. And that's the end of the quote. Incredible. This is what scientists themselves are saying about where the evidence is leading. That even though the Bible claims such an audacious thing, science is not disproving it. On the contrary, the more things that science discovers, it's lending more and more credibility to what we read in the scriptures. So obviously, that author, Michael Denton, is referring to observations concerning how could a universe, not just matter, but we know that the universe is more than matter, right? The universe is also space and time. How could it come into being by itself? That's what he's talking about. That's one of the things that he's talking about. He's also talking about observations concerning DNA, genetic coding. There's not even a theory for how life can come from non-life. And of course, thirdly, he's also talking, as we are learning about in these lectures, that there's also an ever-growing body of evidence showing how remarkably unique and finely tuned for life planet Earth actually is. So, with that as our introduction for today, the way I want to start the lecture today is by inviting you to consider another one of the factors which makes Earth unique in its habitability, which is the existence of gas giants like the planet Jupiter. Saturn is a gas giant, Uranus is a gas giant, but Jupiter is just the gigantic one, the great behemoth that is out there. So I learned this week that Jupiter is mammoth. It is more than 300 times the mass of Earth. That's huge. Jupiter's huge. Now, for a long time, the only planets that we knew of were just the 9, if you count Pluto, which we know recently got demoted from a planet, but counting Pluto, 9 planets of our own solar system. That's the only planets that we knew about, right? But starting back as recently as 1995, astronomers have begun discovering other planets around other stars. And these are called exoplanets because it means that they are outside of our solar system. So they're discovering planets now that are revolving around other stars, not the sun. Now, it was totally expected by astronomers that they would find gas giants, giant planets like Jupiter. But what they have discovered, and let me say that at this point in 2021, I looked this up. Do you know how many exoplanets they have found? 4,455 planets outside of our own solar system. That's pretty incredible. And what they have discovered is this. The closest planet to our own solar system was discovered in 2007. And actually, they knew that it was there. They just couldn't see it, but they knew it was there because they could see that the star that it was orbiting was wobbling. And that's how they find out where planets are. They're able to make detections about things like this. And that's a telltale sign. If you see a star wobbling, it's probably something big revolving around it. And actually, I have an artist's rendition of it, and I'm going to ask Toshko to put the slide up. You know, you can't take pictures of these things because it's too far away, but they can learn about it, and then they can make a picture of it. All right, so there it is. Interestingly, they do not know really if there are rings around this planet or not, but they do know that it's possible for there to be rings. But what they do know, which the artist has included here, is that there is a belt of dust and gas and debris orbiting around the star. So you can kind of see that in this rendering of it, that you can see that dust and gas floating around the star. They also have been able to measure the tilt of its axis, and they also know what is the mass of the planet. Folks, which is not bad for 10.5 light years away. That's how far away it is. You travel at the speed of light for 10.5 years, and you can go visit this nice planet. Okay, but what came as a surprise to them was that this gas giant was very unlike Jupiter in that it did not have a circular orbit. All right, Jupiter has a circular orbit. It's perfectly round. It's almost perfectly round. As it goes around the sun, it goes around the sun in a perfect circle. But this big one that they discovered, it has an elliptical orbit. And when it comes bombing in towards its star, at its closest point, I want you to listen carefully to this. What they have noticed is that that planet is even closer to its star than planet Earth is to our star. All right? Now, knowing what you know from last week about gravity, you can tell, you can see why the star wobbles. Because when that big planet comes in close to the star and then comes whizzing around it on the other side and then shoots out far away on the other side, that gravity is affecting the star itself. It shakes the star. It causes the star to wobble. But it not only makes the star wobble, but it wreaks havoc on the orbit of other planets in that particular solar system. Can you see that? When you have something that big that's flying in really close around the star and then goes shooting out, it's affecting all the other planets too, because it's so massive and it has such a large gravity. And not only does it wreak havoc on those planets, but it wreaks havoc for the possibility of advanced life to exist on such a planet, because the more elliptical that those planets, if there's any terrestrial planets there, the more elliptical their orbits are, or the more that they wobble, the more erratic is the climate. You know, if they're going close to the sun and then far away from the sun, those kinds of things, it affects them. Drastic fluctuations will be on the surface of that planet. So again, in our solar system, guess what? We have like a perfect setup. All right? Jupiter is way out there. It's in a nearly perfect circular orbit, as we are. Folks, we have a very stable big brother. It's always nice to have a stable big brother, right? Some people have a big brother who's drunk and wobbling and he's wreaking all kinds of havoc in the family. Well, folks, we have the opposite with Jupiter. He's like a very stable big brother. He just stays in his orbit, cruising around in a circle, gobbling up all the dangerous things that are out there. So again, in our solar system, it's just a perfect setup. But not only that, as you heard Eric Metaxas mention earlier in that video I showed 2 weeks ago, Jupiter also happens to be providing a very valuable community service for us. And of course, what I'm talking about is I'm referring to that in 1994, George Wetherill of the Carnegie Institution showed that Jupiter is acting as a shield to planet Earth. It's shielding and protecting planet Earth from the impact of many comets. Sometimes Jupiter deflects them with its gravity, and apparently sometimes it just sucks them up like a great big vacuum cleaner. Now, this was illustrated for us in dramatic fashion in the year 1994, which probably most of you remember, with Comet Shoemaker-Levy. And folks, this is one of the things that I remember vividly in my own memory, because not only did we know it was going to happen, you know, people were talking about it for months ahead of time. We knew it was going to happen, but not only that, we had incredible ways to observe it. For example, we had the Hubble Space Telescope was in position and ready to watch it. And we also had the space probe Juno able to stop as it's cruising out there. And it was actually on its way to Jupiter, and it could focus all of its cameras on the big event that was about to happen. And I am not going to say any more about this, because I want you to listen for yourself and see for yourself this incredible video concerning how Jupiter grabbed a comet and not only crushed it up, but then swallowed it whole. So check this out. The video is 11 minutes long. I apologize for that, but I really wanted you to see this whole thing because it's just, you can marvel at the wonder of this magnificent state-of-the-art photography that we are now able to have of Jupiter because of the Juno space probe. And you're going to be blown away. And let me just also say before we start it, this is not a Christian video. I'm not showing you a lot of Christian videos this time. These are scientific videos that I'm showing you. But it explains how Jupiter is so important to planet Earth. So check this one out. 11 minutes about Jupiter.
Everyone knows that Jupiter is the largest planet in our solar system. It's 318 times as massive as Earth and 2.5 times bigger than all the other planets combined. It's a gas giant, and for a long time, scientists haven't exactly known what lies beyond the violent swirling clouds in the atmosphere. But now, scientists have discovered what the inside of Jupiter really looks like. What have they found? And has Jupiter really saved the Earth from total annihilation because of its incredible size? Our solar system began as a disk of dust and gas some 4.6 billion years ago. The first planets to form were the gas giants Neptune, Uranus, Saturn, and Jupiter. Jupiter took shape about the same time as the rest of the solar system, forming around 4.5 billion years ago, its strong gravity pulling in massive amounts of gas and dust from the disk before all the other planets formed. It was the first and the largest. Jupiter is mostly made up of hydrogen and helium, about 90% hydrogen and about 10% helium, almost the same composition as our Sun, which is about 70% hydrogen and 28% helium. Some astronomers call Jupiter a failed star. However, the gas giant only has a mass of 1,000th that of the Sun. Jupiter just isn't massive enough for gravity to trigger nuclear fusion. The beautiful whirling clouds and storms that you see in images, the layer resting on the surface known as the troposphere, are about 31 miles thick and are made up of ammonia, ammonium hydrosulfide, and water, which form the distinctive red and white bands. When you look at Jupiter, you probably think that it must have a solid surface. The fact is that Jupiter doesn't have a true surface. It's mostly swirling gases and liquids, and if you sent a spacecraft there, it would have nowhere to land. But just because the spacecraft wouldn't have a place to land doesn't mean it would fly right through Jupiter's atmosphere and come out unharmed through the other side. This is because extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize any spacecraft trying to fly into the planet. But we've sent spacecraft to orbit and explore the planet. The $1 billion Juno probe, the farthest space probe ever to be powered by solar arrays, was launched towards Jupiter on August 5, 2011, and arrived in orbit around the planet on July 4, 2016. And what we've discovered and learned about Jupiter is incredible. The newest discovery using data collected from the Juno spacecraft found that the colorful stripes of swirling gas and dust you see in Jupiter's atmosphere were found to run 1,800 miles deep and hold so much gas that the mass is about 3 times that of the entire Earth. These belts of wind flow at speeds of 223 miles per hour and disrupt how mass is spread across the planet. It was also discovered that Jupiter's atmosphere is rotating differently, with zones and bands rotating at speeds that are different by up to 328 feet per second. Those bands on different colors you see are actually traveling in opposite directions. Lighter bands move in the direction of Jupiter's rotation, circling the planet faster than it spins, and the dark-colored bands move slower in the opposite direction and take longer to move around the planet. So how does a giant ball of gas floating around in space stay together and form a planet? The Jovian magnetosphere is the cavity created in the solar wind by Jupiter's powerful magnetic field, ballooning 600,000 to 2 million miles, and tapers into a tadpole-shaped tail extending more than 600 miles behind Jupiter. This magnetosphere is the largest and most powerful of any planetary magnetosphere in the solar system. Jupiter's magnetic field is generated by electrical currents in the planet's outer core, which is composed of liquid metallic hydrogen. This magnetic field was found to be almost 20,000 times as powerful as Earth, and rotates, with the planet sweeping up particles that have an electric charge. The electromagnetic storms they generate are so strong that they can be heard by amateur radio operators on Earth, beamed towards us by plasmas and magnetic field lines. These signals are sometimes even more powerful than radio signals from the Sun. This magnetic field traps swarms of charged particles and accelerates them to very high energies, and creates intense radiation that bombards the innermost of its 67 confirmed and named moons, and would destroy anything that got close. Speaking of Jupiter's moons, scientists have recently discovered an FM signal emanating from one of Jupiter's moons, Ganymede. If you want to see a video about this mysterious signal and Jupiter's giant moons, let us know in the comments. By now you may be wondering, does Jupiter have a solid inner core? Studies have found the planet's interior moves as a single body and behaves as if it were a rigid solid, despite its fluid nature. For now, we simply do not know if Jupiter has a solid core or not, but the Juno spacecraft should be able to help discover this, and what the mass and makeup of this solid core is, if it exists. We do know that at Jupiter's core, whatever it's made of, the pressure is about 100,000 times the pressure on Earth. The Great Red Spot is one of the most iconic features of the planet. It's a massive storm the size of the Earth that's been raging since it was first sighted in 1831. Trapped between two jet streams, it's called an anticyclone that swirls about a center of high atmosphere pressure and rotates in the opposite direction that hurricanes do on Earth. It's the largest storm in the solar system, with wind measured around 400 miles per hour. Compare that to the fastest wind speed ever recorded on Earth of 231 miles per hour. One day this great red spot could end up disappearing completely, and scientists say that it's been shrinking since the 1800s, and may only last another 20 years. NASA's Juno spacecraft was able to snap incredible images of the planet as it passed at 5,600 miles above the giant red spot clouds in July 2017. One of the amazing things that was discovered is that deep in the atmosphere, pressure and temperature increase greatly and compress the hydrogen gas into a liquid. This gives Jupiter the largest ocean in the solar system, which is made of hydrogen instead of water. Juno also grabbed some spectacular images of the gas giant's poles, discovering another incredible wonder of the planet. At the North Pole of Jupiter, a huge persistent cyclone is visible, and encircled by smaller cyclones ranging in size from 2,500 to 2,900 miles. On Jupiter's South Pole, the same thing was discovered as Juno did a flyby, and using infrared cameras imaged a cyclone the size of the entire USA, with 5 other cyclones swirling around it in a geometric pattern, which also rotate counterclockwise. The NASA Galileo spacecraft was likely the first to discover these hotspots when it accidentally flew through one on its way to a planned demise to the surface of Jupiter. When the spacecraft was almost out of fuel, NASA deliberately sent the craft on a no-return plunge into Jupiter on September 21, 2003. This was done to protect the moon Europa, which some say has a subsurface ocean that could contain life. It's worth mentioning that we probably should be thankful for the planet Jupiter's size and the powerful magnetic field that it generates, because it's possible that Jupiter has saved the planet Earth from certain doom. People were laughing at the prospect of an asteroid or comet hitting the Earth in the late 80s and early 1990s, but then something happened that would quiet that laughter. The comet Shoemaker-Levy 9 was discovered by Carolyn and Gene Shoemaker and David Levy on March 18, 1993, using the Schmidt telescope at Mount Palomar. Scientists calculated the comet was originally 1 to 1.2 miles wide. However, tidal forces from Jupiter's powerful gravity had broken the comet into more than 20 pieces as it made its close approach to the planet sometime in 1992. But the biggest revelation was scientists saw that the fragments were going to smash into Jupiter, and luckily for NASA, its Galileo orbiter was still on its way to the gas giant. Many Earth-based telescopes and orbiting spacecraft such as the Hubble telescope all were focused on the incredible event that was about to happen. The fragments of the comet were lined up like a freight train and collided with Jupiter's atmosphere, unleashing the force of 300 million atomic bombs. The fragments created huge dark spots in the clouds that measured 1,200 to 1,900 miles and heated the gas giant's atmosphere to temperatures as hot as 53,000 to 71,000 degrees Fahrenheit. If a comet of this magnitude hit the planet Earth, the results would be devastating, with impacts sending dust and debris into the sky, which would cool the atmosphere and absorb sunlight, and envelop the entire planet in darkness. This historic Jupiter comet impact is what led to planetary defense. But fear not, this type of collision was very rare, and scientists say probably only occur every few centuries. Or do they? On August the 7th, an amateur astronomer was looking at Jupiter through his telescope when he captured an asteroid colliding with the atmosphere of Jupiter, creating a white flash visible in the clouds. Some scientists say these impacts are inevitable, with the amount of objects floating around in space and Jupiter's massive gravity tugging on anything that gets close to it. We could say that Jupiter's like Earth's big brother, and likely protecting us from asteroid impacts.
All right, so I don't know, I just love that. I just eat it up. Oh boy. So as you can see, in very recent times, we have witnessed with our own eyes the surprising way that Jupiter stands kind of guarding planet Earth, protecting it from many comet strikes. And I also learned that Saturn is doing the same thing, and so is Uranus. So those are both providing the same function, just not to the same degree that Jupiter is. And when we look at the planets that are closer to ourselves, closer to planet Earth, it's obvious that they also are engaged in protecting planet Earth from bombardment with asteroids coming from the asteroid belt. Now, the asteroids are mostly between the orbits of Mars and Jupiter. That's where there's a whole belt of these asteroids. Our first line of defense is Mars because it's right there at the edge of the asteroid belt. But we also know that Venus is taking some hits for planet Earth as well. So in summary, we can say that our solar system is set up in a unique way so that Jupiter is out there protecting planet Earth, as well as these other planets. So to conclude this part of the lecture, I want to show you a quick video interview with astrobiologist. That's somebody who looks for life on other planets, an astrobiologist. His name is Bijan Namadi, who is answering the question, what kind of factors can make a planet inhospitable? That's the question that they're asking him, inhospitable for life. And he's referring to all the exoplanets that have been discovered in recent times. So again, that means the planets that are not in our solar system, but in other solar systems. But listen to the interview because this is a good summary of what I've been saying. And I'm just going to show you, I think it's about 3.5 minutes, this interview.
So when we think about all that we've seen now with the ground-based and space-based observatories, it is really a spectacular harvest of exoplanets around other stars. And what have we learned? Well, we see a very large number. The ground-based radial velocity technique has given us this large harvest of Jupiter-mass planets. A lot of these planets have the characteristic, though, that they are, a lot of them are in these highly elliptical, high eccentricity orbits, and then many of them are also in these tight circular orbits around their host star. So this tends to, what the picture that it has basically given us is that in the majority of systems, what you have is these high eccentricity, very large gas giants that have the ability to be very disruptive. And these migrate inwards and totally disrupt the inner planets where, like, for example, the Earth would be. So in that sense, the Earth came off really, really lucky because in our case, all of our gas giants, like Jupiter and Saturn, they're in almost perfectly circular orbits. The Jupiter's at 5 astronomical units. That's 5 times away from the sun as we are. And so it is just politely sitting there in a perfect circular orbit, cleaning up the debris of the solar system for our benefit. and providing a very rare, by the view that we have from these exoplanet discoveries, a very rare kind of stable, clean environment for the Earth. The other thing is when you look at the Kepler planets, you see that the great majority, the vast majority of these are very close in to the host star. Now the Kepler technique, which is a transit technique, is looking for the obscuration of the starlight as a planet goes in front of it, transits in front of it. Now you can imagine as the planet goes far from the star, the likelihood that you would catch it goes down. So there's a bias in the measurement to only see the planets that are close in and miss the ones that are farther out. But you can calculate what that bias is. And when you even correct for that bias, you still see that in the majority of cases, even more than this detection bias, that the exosystems are all filled with planets that are very close in. Planets that are too close in are typically not in the habitable zone. The other thing is that most of the planets that Kepler has seen are around M dwarfs. These are cooler stars, redder stars. The habitable zone for M dwarfs is very close in relative to our energetic G-class star. What is the consequence of that? If you're so close, if your habitable zone is that close to the host star, now you are in this dangerous tidal lock radius. You're inside of the tidal lock radius, where the planet's orbital period gets matched to its spin period. And so the same face of the planet is constantly exposed to the star. One side boils off and just desiccates, while the other side, it basically snows down. And as a result, you have more or less a desiccated, very inhospitable planet, nothing remotely like the hospitability of the habitability of the Earth.
Okay, so you kind of knew that. I had mentioned those things before, but now I want to turn my attention to another important factor that scientists have noticed concerning the fine-tuning of planet Earth. Specifically, astronomers have noticed that Earth has a very large moon. Did you know that our moon is almost 1/3 the size of our planet? That's huge. It's enormous. In fact, when you compare the proportions, the size of the various moons in our solar system with the size of their various host planets, Earth's moon is, get this, 50 times larger than any other moon when you compare it with the proportions. So why does that matter? Well, there's 3 reasons at this point that scientists have discovered that make this significant. First of all, having a large moon is so important in generating the kind of tides, ocean tides that we enjoy on planet Earth, which play an essential role in habitability because they're cycling the elements all around the globe. The gravity of the sun is 40% responsible for our tides, but the gravity of the moon is 60% responsible for our tides. Secondly, it also slows the rate of Earth's rotation. Having a large moon, what it does is it sort of puts the brakes on so that our planet does not spin too fast. But the most important thing that scientists have noticed is that the large moon plays an essential role in maintaining the 23-degree tilt upon which the Earth is spinning on its axis. If we did not have a large moon, then what would happen is that Earth would be more affected by the tug of war. We could call it a tug of war because the sun has enormous gravity and Jupiter has enormous gravity. And if we didn't have our moon stabilizing our tilt, we would be the subject of the battle between Jupiter and Earth. And what would happen is our tilt on our axis would become varied. It would it would be widely varied. In fact, they say it could vary up to 90 degrees. And that's a lot of degrees, 90 degrees. That would have a devastating effect on the habitability of planet Earth because The steady tilt of the Earth is what keeps our seasons so stable. That's the whole thing about the tilt of the Earth, is that it keeps the seasons. What we're experiencing right now as we gently move into another season, that's all because of the tilt, that it's exactly at the right amount. And for most of Earth's history, our tilt upon this axis at 23 degrees has not varied. Astronomer Jacques Lascar, who is the person who has done most of the calculations concerning the moon's influence on the Earth's tilt, says that the situation on Earth is, surprise, very peculiar. Most terrestrial planets have chaotic behavior in terms of their spin axis, but the reason for that is because they don't have a big moon. They don't have an abnormally large moon like Earth does. So you can see that this is another example of fine-tuning of the Earth for life. But the wonder does not stop there, because the next question is, well, how did Earth get such a nice moon? That's a really good question. Why do we have a great big moon like this? Is it easy for a terrestrial planet to get a nice big moon like the one that we have? And as you might guess, the answer is no. In fact, even a few years ago, scientists were absolutely puzzled by the moon because it is so big in comparison to its planet. That basically, that scientists said it's impossible. It's impossible for a terrestrial planet to have a moon that big. How could a little planet like Earth, with its dinky little force of gravity, ever capture a gigantic moon like that? The moon would have to be going extremely slow, just sort of wandering. And even then, they didn't think it would be possible. But in fact, now, based on our trips to the moon and the samples that we have collected there, the predominant scientific theory about how the Earth came to have such a prize-winning moon is that, guess what? Another planet smashed into planet Earth during the early days of Earth's existence, and the outcome of that collision was a moon like ours. A moon like ours could have formed, and therefore would be in similar composition to what we see planet Earth having. That's what we've been able to determine because of those samples. Now, folks, that idea that there was a collision was suggested back in the 1970s, but there was no good way to test to see if that really was what could have happened. But as you know, a lot has changed since 1970, because we have been able to make a lot of progress in scientific discoveries precisely because we have computers. And what they have been able to do is use computers to simulate what would happen if one planet of a certain mass smashed into another planet of certain mass, because they can type all this in and make a simulation through the computer. If they did it at different angles, what would happen if they had such a collision? So I have another video that I want you to see, which is put out by the University of Illinois at Urbana-Champaign. Again, this is not a Christian video, but I think as you watch it, you will see that we are looking at an event, the moon forming event, that must have been very finely tuned. It had to be exactly right. In fact, to the highest degree, in order to achieve the result of such a life-friendly moon. So this video is 6.5 minutes long concerning the moon forming event, and just enjoy this. Very interesting.
Climate. There's a fundamental connection between our studies of the origin of the moon and the physical samples that were brought back by the Apollo mission. the actual rocks from the moon. When those rocks were first studied, we learned several very significant things. One, we learned that compositionally, those rocks are extraordinarily similar to the upper layers of the Earth. If you look at an element like oxygen, its distribution of different isotopes of oxygen is essentially identical in the moon and the Earth, whereas it's very different in meteorites from Mars or the asteroid belt. Another clue, another constraint we learned from the Apollo samples is that the moon rocks appeared very dry compared to Earth rocks, almost as if they had been heated to a high temperature and that they had lost the elements that tend to vaporize easily upon heating. And that suggested to us that the process that formed the moon must have been a high energy event. So we think the moon formed when the Earth was struck by a very large object as the Earth was forming. So this would have been a separately formed planet that was vying for dominance in the inner solar system along with the Earth and other growing planets. But it collided with the Earth and ultimately was absorbed by the Earth and gave birth to our moon. So in terms of the impactor, which we often call Theia, we think that based on its mass, that it would have been as big as the planet Mars. Before it collided with the Earth, it would have had an iron core and a silicate mantle, like the Earth, and it would have had about 10% of the mass of the Earth. We think initially the inner solar system had maybe 20 small planets, and it was through collisions between these planets that we eventually ended up with our final 4 terrestrial planets. Now, the last of these big collisions on the Earth was the one we think formed the moon. The reason that we focus on a Mars-size impactor is that that is the impactor size that if you hit the Earth with a Mars-size impactor at an off-center angle at the expected speed, you will start the Earth spinning with about a 5-hour day. Now that's a very rapid spin rate, but it turns out that is what is needed to agree with our current 24-hour day with the moon at its current distance. The moon is moving away from the Earth, so we know when the moon first formed it was much closer to the Earth and the Earth was spinning much faster. So the idea that the moon formed by this giant collision with the Earth was first proposed in the mid-70s. And yet, we couldn't test the idea initially. For smaller scale collisions, you can perform experiments in the laboratory, but you can't perform an experiment of what happens when 2 planets collide in any laboratory setting. To do this, you need to build a computational model to simulate the planets and their response to the collision. We can use our computer simulations as, in essence, a virtual laboratory to test how the outcome depends on things like the size of the impactor, the impact speed and angle, and use the overall results to assess the likelihood of forming a moon like ours. So we're simulating this final large collision with the Earth. From the perspective of someone on the Earth at the time, what you would have seen is an enormous object approaching the Earth, many, many, many times larger than the full moon in the sky. It would have hit the Earth at an oblique angle. On a time scale of a few hours, an enormous shock wave from the impact would have propagated around the entire surface of the Earth. The vaporized rock from the initial impact point would have been ejected out and it would have flowed around the entire Earth. And the Earth would find itself enveloped by a thick atmosphere, but not like an atmosphere we know today. This would have been an atmosphere of vaporized rock with a temperature of more than 5,000 degrees. The momentum, the force of this collision, is enough to start the Earth rotating very rapidly. And so only hours after this impact, the Earth has a rapid rotation rate. Now we think on a much longer time scale of about 100 years. That disk will cool, the vapor will condense, and out of that disk, through collisions within the disk, the moon would have grown and accumulated. So although we think we have a good idea about how the moon formed, the exact details of this event are still being debated, and this is in large part a testament to how those samples that were returned decades ago are still driving active science debate as ongoing analysis provides us with more clues from those samples on how the Earth-Moon system formed.
Now, it certainly is exciting, at least to me it is, exciting to think about how the moon keeps the Earth from spinning too fast, how it generates the tides, the right amount of tides, and regulates to perfection the seasons on planet Earth. But that's really not all. I mean, if you just read between the lines, there's so much else going on. There's many other habitability important things that happened when God engineered to perfection this moon forming collision. You know, if you go to the website Reasons to Believe, you will find there an article called The Remarkable Design of the Solar System's Turbulent Youth, Part 2. And in that article, Hugh Ross lists 10 essential for habitability things that happened because of that collision that God designed. And I'm not going to read all 10 of them to you because some of them are a little more technical than others, but let me read six of them to you. So just listen to this, and just give me like 10 more minutes. If you do have to go, I understand, but I just have a little bit more material. So this is what the article says. The moon-forming impact presents all humanity with a dramatic set of evidences for supernatural, super intelligent design for our specific benefit. Thanks to the exquisitely fine-tuned nature of this impact event, the collision, here's the first one, the collision replaced Earth's thick, suffocating atmosphere with one that possesses the perfect air pressure for efficient lung performance, ideal heat trapping capability, and just right transparency for efficient photosynthesis. I mean, that's like 3 of them right there. Number 2, the collision gave the new atmosphere the optimal chemical composition to foster advanced life. Number 3, the collision augmented Earth's mass and density enough to allow it to gravitationally retain a large but not too large quantity of water vapor for billions of years. Number 4, the collision raised the amount of iron in Earth's core close to the level needed to provide the planet with a strong, enduring magnetic field. This magnetic field shields life from deadly cosmic rays and solar X-rays, as I mentioned in a previous lecture. Number 5, the collision increased the iron content of Earth's crust, permitting a huge abundance of ocean-dwelling phytoplankton, permitting a huge abundance of ocean-dwelling phytoplankton that in turn supports the entire oceanic food chain and provides the oxygen for advanced terrestrial life. And then the last one I'll mention is number 6. the collision produced the moon, which gradually slowed the Earth's rotation rate so that eventually advanced life could thrive. All right, so let me just conclude this section by pointing out that one of the things that they have noticed as they keep experimenting with these computer simulations, to see how in the world it could have possibly ended up that we had such a large, life-friendly moon. They are noticing things that it seems like the impact itself must have been extremely well fine-tuned so that it happened at exactly the right time in Earth's history. The planet that hit it was exactly the right size, and it was made up of exactly the right composition of materials. It was traveling at exactly the right speed, and it was spinning at exactly the right speed when it hit the Earth. And of course, it had to hit the Earth at exactly the right angle. I mean, if it was like a straight-on collision, that would have been the end of planet Earth. If all these factors are not in place, then the simulations fail. In other words, the more we look at this impact event, which obviously, they're still learning a lot about it, but the more we look at this event which caused our very special moon to form, we see that the event itself is exceedingly well fine-tuned. It's very hard to believe that it happened at random or just by chance. It's extremely well designed. The odds against it forming are huge. Instead, what we could say is it really seems to show the fingerprints of God. And now I will conclude this lecture with a short video, which is also taken from the interview with astrobiologist Bijan Namadi, the guy that I showed you earlier. In this part of the interview, they're asking him about how the field of astrobiology has changed over the years, because it's not a field of study that has existed for a long time. In this part of the interview, they're asking him about how it's changed in recent years, meaning how the search for intelligent life has changed over the past few decades. And when you listen to his answer, again, it's not a Christian video, but what you see is essentially what he is saying is that when you see a planet like planet Earth, because it is so rare and peculiar and unique and apparently finely tuned, you do not think to yourself, well, probably there are many planets like that. On the contrary, you think to yourself, this planet is unique to a degree that's just utterly staggering. So I want you to listen to this short interview, just a couple minutes.
Explosive beginning to the universe. The field of exoplanets is only now, 23, well, you could say it's 23 years old since the first discovery that has been was confirmed. And as time went on, and also as astrobiology matured, and is maturing still, the inference that you can make from observations is beginning to morph from one type to another. If you're coming fresh into a field of study, just your observations tend to tell you what is likely and what's not. What you're observing, it tends to be, you consider that likely, and what you're not observing is unlikely. And that's all good, and that kind of guides your theory. As things mature and you have a theoretical basis and then you've got many more observations, you're now beginning to actually have a prejudice. You are now having not a bad prejudice, but you have a sort of a seasoned scientific and philosophical framework with which to judge what you're observing. In a way, it's like this. If you are walking down the beach and you see a little buildup of sand that looks just like a little pileup, you may not think of it as anything remarkable. But now if this Pylab looks more cylindrical. It starts kind of raising your curiosity, because now you have a priori notions of how likely is it for waves to generate something that looks like a vertical cylinder. Now if you see little turrets on the top that looks like a little castle, now your a priori feelings about, or estimation that's going on in your head, you're going, that's not waves. And in a sense, that's what's going on as we keep going forward in the exoplanet and astrobiology, kind of moving away from the place where an observation of an exoplanet teeming with life right near us would have us say, oh, gee, that must be easy. No, we already know it's hard. It's just like the guy with the sandcastle. He's not going to say, oh, gee, I guess sandcastles are easy to make by waves. No, that a priori knowledge that he's accumulated of what waves can and can't do tells him what mechanisms he needs to rule out when he sees the sandcastle. And in the same way, now if we ever see an exoplanet with life, we now know a lot more about what chance and materialistic processes can and can't do, and what is required for life to be there. And the way we're going to analyze that is going to look different.
Now, if you read between the lines there, I don't think I have to tell you what he's saying. The likelihood of finding an Earth-like planet teeming with life is becoming increasingly unlikely. Even though Carl Sagan thought there's probably millions of them in our own our own galaxy. Not only is it unlikely, but look at this man. I mean, look at the analogy that he uses. He's saying that what we see here on planet Earth is so unusual that anybody who is familiar with the science aspect of what it takes to have advanced life on a planet is going to liken it to a man who walks on the beach and sees a sandcastle. And he knows this sandcastle did not happen by chance. It demands a better explanation than that. And folks, that's what this is all about. That's our whole goal when using this subject in apologetics. We simply want to help people see that currently there are many things that science is observing and noticing which seem to be pointing to the fact that a better explanation is needed than just chance and time. It's so remarkable. It's so incredible, the discoveries that are being made. And folks, it's like we live at a time where this is just being put into our laps. It's almost like it's not fair for us to not talk about it. We really want to, the Bible claims that in the beginning God made the heaven and the earth, and that is what we believe. That's the better explanation, that there really is a God. But especially if we come across somebody who's saying, I don't believe in God because of science, this is just a whole lot of exciting information where we could say, boy, I don't know how you came to that conclusion. How did you come to that conclusion? Because when I looked at it, science is one of the main things that affirms and confirms that there really is a God. So let me close just quickly with a prayer. Heavenly Father, thank you for this opportunity to spend an hour together thinking about the wonder of your creation, the spectacular fine-tuning of your creation. It's almost like the more we learn of how the universe formed, we see your hand all over it. And we pray, God, you continue to make us excited and especially make us ready to engage the culture around us, talking about you and the hope that we have through Jesus Christ for salvation. In Jesus' name we pray. Amen. All right, thank you, everybody. Thanks for, yeah. That was excellent. Oh, good.